Welcome to Chapter 4, Homework Questions 95 through 100. Question 95. Use an area, model, a tree diagram, or refer to the table you created in Problem 4-10 that represents the sample space for the sum of the numbers when rolling two standard six-sided dice. Part A. In a standard casino dice game, the roller wins on the first roll if he rolls a sum of 7 or 11. What is the probability of winning on the first roll? So you really need to go back to question 4-10 or recreate that table so that you know what all the possibilities are. There's 36 possibilities, and out of those 36, there are, there's 6 that give you a sum of 7, and there are 2 that give you a sum of 11. So that's a total of 8 out of 36 for your probability. On B, the player loses on the first roll if he rolls a sum of 2, 3, or 12. What is the probability of losing on the first roll? So once again, going back and looking at that chart, there's one possibility, or one way to roll a 2. That's a 1 and a 1. There's 2 possibilities of rolling a 3. You could do a 1, 2, or a 2, 1. And then there's one possibility of rolling a 6, which is or a 12, which is a 6 and a 6. So there's a total of 4 out of 36. Once again, going back to that table that was created in 4-10. Part C, if the player rolls any other sum, he continues to roll the dice until the first sum he rolled comes up again, or until he rolls a sum of a 7 or 11. Whichever happens sooner. What is the probability that the game continues after the first roll? So if you take a look at this one, what is the probability that the game continues after the first roll? So let's start with a 1 and then subtract what we know. So we know 8 out of 36 will actually win. So we want to take those away, because if we roll a 7 or 11, a sum of those, the game's over. We know they lose if they roll a 2, 3, or 12, which would be a 4 out of 36. So once again, if that happens, then the game's over. So what is going to be left? And so we could change 1 to 36 out of 36, subtract the 8 and the 4, and that will leave us with 24 out of 36 that the game will continue after the first roll there. Question 96. A player in the casino dice game described in problem 4-10 rolled a sum of 6 on his first roll. He will win if he rolls a sum of 6 on the second roll, but lose if he rolls a sum of 7. If anything else happens, they ignore the results and he gets to roll again. Part A, how many ways are there to get a sum of 6? Once again, going back to that table on 4-10, if you add them up, there are 5 ways to get a sum of 6 out of 36. Well, I guess it only asks how many ways, so make sure I answer the question right. There are 5 ways. How many ways are there to get a sum of 7? Once again, if you go back to the table and look, there are 6 ways to get a sum of 7. So then how many possible outcomes are important in this problem? And so the possible outcomes on this, there are 5 ways to get the sum of 6 again when he rolls again, or 6 ways to get the sum of 7, and that would, end the game, and then the game wouldn't continue. So that means there are 11 possible outcomes that are important to this problem. Not that are just total possible, but that are important to the problem. And then D says, what is the probability of getting a sum of 6 before a sum of 7? So since all the other outcomes don't necessarily matter, because you'll just roll again if that's the case, the probability of getting a sum of 6 would be 5 out of a total possible outcomes that are important, which would be 11. Question 97, for each diagram below, solve for x. Name the relationship you used. Make sure you show your work, of course. So we have 2 right triangles on part A. We could use Pythagorean theorem to find the hypotenuse of this smaller triangle. Once we find the hypotenuse, that's the leg of this triangle, which then we could use the Pythagorean theorem to find that as well. So if we start with, we'll just call this y. We'll say 3 squared plus 4 squared is equal to y squared. That's 9 plus 16, and that is 25. The square root of that is 5, so we know this is 5. Now we can use Pythagorean theorem again. 5 squared plus 12 squared is equal to x squared, and that is 25 plus 144, and that is 169. So when you take the square root, you get x equals 13. And so on this, we used Pythagorean theorem. We actually used it twice to be able to solve this. Question B, we have a triangle. We have a couple sets of parallel lines, actually 3 of them, this one, and this one, and we're looking for the value of x. So we can use the triangle angle sum theorem to figure out this angle right here, 180 degrees minus 35 degrees minus 65 degrees will give us 80 degrees, so we know that represents the 80 degrees. We also know, let's see, using our parallel lines, this parallel line and this one, that we have our, trying to look here, this angle should be the same as this angle, and that would be our alternate interior angles. And if that's the case, then it looks like we have solved for x because it would represent the 80 degrees. So we use the triangle angle sum theorem, and then here we used alternate interior angles knowing that they were congruent. So x is equal to 80 degrees. Question 98. The area of the rectangle shown below is 40 square units. Write and solve an equation to find x, then find the dimensions of the rectangle. So if this is true, we have let's see, we know this area is x squared, this one is 5x, we have 2x, and we have 10, and it says we know the area, so we'll just add all this up. X squared plus 7x plus 10 is equal to 40, since it does tell us what the area is, and then we can solve this quadratic equation using one of our methods that we know. So we subtract 40, we get negative 30. You could use your diamond. What are factors of negative 30? X squared, that will add to give you 7x, and that will be 10x and negative 3x. So now we know this would be x plus 10 and x minus 3. And then we can use the zero product property to solve for x. X equals negative 10 and x equals 3. So here are 2 solutions for x. It also wants us to find the dimensions. Well, if x is, let's go with negative 10. That's not going to make any sense, but negative 10 plus 2 is negative 8. We don't have a dimension that is a negative. It's a length or a distance, so that won't work. So x equals negative 10 won't help us find the actual distance here. So therefore, we're going to have to use only x equals 3, and that will be 3 plus 2. And so that'll be 5. And then over here, we're going to get 3 plus 5, and that's 8. So therefore, we know that the dimensions are 5, let's see, it says square units, so we'll just use 5 units by 8 units. And those would represent the dimensions. And we don't use the negative 10, even though it solves the problem, it doesn't give us a value for x that would make sense in the problem. Question 99. Based on the measurements provided for each triangle below, decide if the angle theta must be more than, less than, or equal to 45 degrees. Assume the diagram is not drawn to scale. Show how you know. So in part A, you have a right triangle. So we know that 2 other angles that are on the triangle must have a sum of 90 degrees. Therefore, the longest side, which is 4, must have the larger angle. And so if it has a larger angle, they can't both be 45 because the side lengths are different, which means this angle would have to be larger than 45. And if that's the case, then this angle has to be less than 45 degrees. So theta on part A is less than 45 degrees. Part B, we have another right triangle. And we have a hypotenuse of 18 square roots of 2. And then we have the leg as 18. So on this one, we might want to go ahead and find the third or the second side length of the triangle by using Pythagorean theorem. We have 18 squared, call this one x, plus x squared is equal to 18 squared at 2 squared. Whoops, 324 plus x squared, and then when you square 18 squared at 2 squared, you get 648. When you subtract 324 from 648, you get 324. So when you take the square root of both sides, you get x equals 18. So now we see that the side lengths of the right triangle are congruent, which therefore means that theta would have to be equal to 45 degrees. So they both actually would be 45 degrees on that one. And then on part C, since once again we're back to having the side lengths of the triangle, since this value is 8 and that's bigger than 2, then the angle across from it has to be greater than 45. It has to be the larger angle of the two, and since once again it's a right angle, then we know they have to be, the sum has to be 45. So therefore on this one, theta would be greater than 45 degrees. Question 100, find the slope of the line through the points. Then find at least one more point on the line. So we can find the slope of the line by doing delta y over delta x. So this would be 86 minus 16 and negative 5 minus 95. So 86 minus 16 would be 70 over negative 100. So negative 0.7 would be the slope, or negative 7/10 is fine. Then find at least one more point on the line. You could use that slope, and even if you had it as negative 7 over 10, you could take one of those points and just go down 7 units and right 10. So for example, if I'm going to take the point 95, 16, since this is delta y over delta x, if I change my y by 7 units in the negative direction, that could be 9. And then 10 units for your x would be 105. So that would be an example of another point on the line. You could also write the equation of the line and then find another point that way. So kind of lots of different ways as to how you could approach this problem. That was just one example on how to do it.